Knox Grammar School acknowledges that the land on which we learn, play and work is situated on the traditional lands of the Greenguy people of the Eora Nation. We acknowledge these traditional owners of this land and acknowledge their living cultures and the unique roles that they have played in maintaining life, language and culture in this region. We pay respect to the elders past, present and emerging, and to all Aboriginal people.
My name is Sue Floro and I'm the head of Knox Grammar Preparatory School in Sydney. Today, my colleague Ian Fairhurst and I are going to be talking about deep learning through the effective use of technology integration. Our curriculum framework reflects our understanding that deep learning doesn't happen in one lesson, 1 week or 1 unit of work. Deep learning is the result of the layering of carefully scaffolded learning experiences over time through repeated and authentic exposure to outcomes, concepts and skills. Our framework is focused on the future, as is the way our students curate and showcase their learning in both real world and virtual spaces.
Hi everyone, I'm Ian Fairhurst from Knox Grammar Preparatory School in Sydney, Australia. At Knox Prep, we've created a framework that uses a balance of explicit instruction and guided inquiry, understanding that research supports first one, then the other, particularly geared towards reducing the load on working memory and allowing students to apply the learning that they do about Australia and the Australian content to context globally. We'll also today be looking at frameworks and mental models for developing a sense of empathy, student agency and altruism from a range of different sources. The Feel, Imagine, Do, Share framework from the Design for Change organisation, empathy mapping, the Knowledge to Action framework from World Savvy, and also the design thinking process.
Simon Sinek always talks about beginning with why, and our why was many and varied. In 2018, our kindergarten cohort was the first cohort that would graduate in the 2030s. We know, based on the research that we did, that the skill set that our students will require from 2030 and beyond is vastly different to the skill set that we needed when we graduated, and certainly when their parents graduated from university. It's a world that is full of greater uncertainty than we had in the past. The literature tells us that the skill set that they will need is vastly different. And if you have a look at this slide, the increases in critical thinking, communication, collaboration, the ability to problem solve, the ability to work together, they're all of the skills that we felt our students were going to need that was slightly different to the work that we had been doing in the past. Our curriculum was rather siloed. Our students are bright, but they were very used to being spoon-fed lots of information, in drip-fed even. So what did we do? We got rid of textbooks and we put microbits on the book list instead. We run a one-to-one iPad program, and we decided that we would develop a cycle of inquiry that would begin in kindergarten and spiral all the way through to year 6, increasing in depth and in complexity each year. We started with 3 guiding principles. That is from the work of Mark Rigotti, who is the former CEO of Herbert Smith Freehills. And he talked about setting the direction, not the destination, allowing and facilitating rich conversation, and creating capability to evolve the solution. So in identifying that our concerns were a siloed curriculum, disconnected learning, and students who didn't have that great sense of agency, these were the 3 principles that we based the work that we did on. The other piece that comes with this is minimal rules. So we didn't box our people into a very strict framework of what they were going to do and how they were going to do it. We really did give them ownership and agency over the work that they did. This was our vision. Key words here are voice, choice, agency, and making a difference, and most particularly to be driven by the responsibility of making a difference. This is what we set out to achieve in a nutshell. Where is the technology? We're at an EduTech conference. The technology is deeply embedded into each of the inquiries that our students undertook. It was based on a conceptual lens with a real sense of global mindfulness and ensuring that our students would understand their role in making the world a better place. There is no standalone technology use at the preparatory school anymore. All of the tech use that we do is technology to create and embedded quite deeply into the units that our students participate in. We made a conscious decision that we would utilise an E-STEAM philosophy or platform. Small e for empathy. If you're going to solve great big world problems, you have to understand the life and the times and the situation or scenario that the people who are involved that you're trying to help are living in or experiencing. We also wanted STEAM rather than STEM, because acknowledging that the A or the arts and aesthetics is as important if those solutions are going to be adopted. So we developed one whole school program of Noxigations inquiries that were conceptual, transdisciplinary, involved the solving of authentic global problems through a collaborative lens. You'll see that there are 5 units that stretch across the page, and from K to 6, this is where that lovely spiral of inquiry starts. So what are those 5 domains of learning that I talked about? The first is tinkering towards tomorrow. This is innovation at its best. We work on the definition of innovation as building on or making better that which already exists, and we use technology to do that. Sustainable solutions, which is much more than just recycling and composting. Our students or our sustainable solutions spiral does increase in conceptual depth quite significantly from K to 6, beginning with very, very close to home and moving out to much more global scale type problems. The next domain is the interconnected systems domain. This is where students investigate that interconnection of all of the systems of the world, transport systems, ecosystems, government systems, all of the systems thinking that we're hearing so much more about. Our students are learning to delve into that process. Stories of the world and its people. You can't empathise with someone unless you do it through story. So getting our boys to understand the stories of the people, past and present, and making predictions about the future. And whilst this unit is more historical in nature than the others that we do, there is certainly a significant degree of educational technology that's used in order to create some of those products that come out of that unit. And this is the one that I'm more excited about than any other. This is the call to action that's built into every one of our units, but this unit takes it that little bit further. It's the unit that expects that our students are going to step out and make a difference, whether they are in kindergarten, year 3, or in year 6.
Our Noxigations inquiries are transdisciplinary, meaning they involve aspects of history, geography, science and technology, English, mathematics, and the creative arts. Teachers work together to craft experiences that allow the boys to understand the relationship between subject areas, honouring each individual discipline, whilst contextualising each in real-world applications. The rich, purposeful use of technology has also deepened student understanding and has enabled boys to realise their ability to make a difference in the world. Noxigations units are future-focused, problem-based, and involve deep investigation into issues that matter. In terms of the deep integration of technology in our primary school environment, we reference 2 particular models: the SAMA framework, standing for Substitution, Augmentation, Modification and Redefinition, and also the Rigor Relevance framework. The ultimate goal for our students is for them to become powerful creators of technological solutions, with the ability to apply those solutions in real-world unpredictable situations. A specific example of the deep integration of technology into our primary school inquiry units is our Year 6 unit on Tinkering Towards Tomorrow. Over the course of the inquiry unit, students research a community that has been impacted by a natural disaster. They specifically look at the science behind the disaster, where it occurs and why. Also looking at human impacts, the communities that are affected, and how using current technological solutions this disaster could have been prevented. Each student then uses their microbit device, plus a range of peripherals, to recreate and improve upon an existing disaster detection system. The following video demonstrates the deep and authentic integration of technology within this task.
is a natural disaster detector that I built, and it detects typhoons. I feel really proud. I really love finding how to solve problems. You're just developing ideas and making them into reality to solve problems. I love solving problems.
This is a device I've made to detect earthquakes. There is a 3D printer that I've created a shell for this device. Obviously there will be a lot of things down below the surface, so having a shell to protect the device is really important.
Ultimately, what we're really encouraging with the microbits is for students to develop a wide range of open-ended solutions. This really allows the students to demonstrate a depth of competency at an individual level. By providing these open-ended tasks, we're not putting a ceiling on the boys' levels of individual creativity. The next 5 minutes will specifically look at frameworks and mental models for developing a sense of empathy, student agency and altruism in your students. We use a variety of frameworks across the prep school based on the projects and also the age of the students we're working with. The first is the Feel, Imagine, Do, Share framework, which has been developed by the Design for Change organisation. Empathy mapping, which is a common process in industries where they're specifically designing solutions for identified users and sections of society. The World Savvy Knowledge to Action framework, also known as K2A. Each of these frameworks is complementary to or is based on the design thinking process. And at the heart of each of them is about helping students to understand and to empathise with the people, places or environments that they are designing solutions for. The FIDS framework stands for Feel, Imagine, Do and Share by the Design for Change organisation. In Year 2, our students were working on a Tinkering Towards Tomorrow design challenge. The students were looking at modifying arcades to make them more accessible for people in society who may have a disability or an impairment. The students designed and built cardboard arcade games using their microbits to create score counters. They then used the FIDS framework to modify their design and make it inclusive for people in society that may have an impairment or a disability. They follow the FIDS process to help them empathise and to understand that there are people in our community that do not have the ease of accessing the everyday things that many of us take for granted. The students also went through an empathy mapping approach. By visualising a person who has an impairment or a disability, they could go through the process of thinking, when they're playing their arcade game, what would this person say? What would they think when they're completing the arcade game challenges? What would they do, and what limitations might they have? And how would they feel if they could or could not access this particular part of the game? In our K to 2 years, we also start introducing the design thinking approach, specifically looking at putting empathy and STEAM together. They then go through a process of mapping out, do they notice a problem and where is it happening? Who or what is being affected and how? Can they think of some solutions? Then can they actually build and prototype something that solves the problem? They then critically test their model, specifically looking to see whether it solves the problem and investigating why or why not that might be the case. They do an audit at the beginning of the unit. They count how much plastic has gone into their waste bin at home, how much cardboard, how much metal, and then they count at the end of the 8-week unit, and that all gets aggregated together to try and see how much impact that they have had in their homes. The typical one the boys start to think about is how much packaging. You go to the counter, you pick something up, you walk away, and within 5 steps you throw away X amount of stuff. So typically those are the sorts of things the boys start to think about. An example here you can see from Henry on the left was he designed a better sushi packaging box, because he said every time you go for sushi you pretty much throw away the container, the packaging, the elastic band, the little sushi soy fish. This is a Year 2 boy, so he'd be 8 years old, and he's looking at his own practice in his own family. So he came up with this new design. We used Tinkercad, free application online. The boys very quickly get used to how to extrude those shapes, how to drop in holes, how to use torus shapes as handles, all these sorts of things. And so it's a beautiful amalgamation, and as I said before, it shows how integrated technology can actually be, where we don't need to be specifically having a lesson that's just all about shapes in mathematics, but we can actually cover that and apply that within design thinking task that the boys are doing. Our Year 4 students have been challenged with creating a CoSpaces app, which will be specifically looking at how we can re-engineer Australia to better manage its water supplies. The students have created different scenes to actually show how we can use artesian water to prevent evaporation, and also to look at the movement of water around Australia. CoSpaces allows the students to create both virtual spaces and to also utilise 360-degree photospheres. As the students progress through their understanding of CoSpaces, they're able to utilise code to make the experiences more interactive. This is a phenomenal way for the students to demonstrate their depth of understanding around their inquiry units.
Over the past several years, our staff have been exploring augmented and virtual realities to enhance and deepen authentic inquiry learning experiences for our students. We have now begun dabbling in the world of immersive platforms to further connect all members of our community to learning that our students are doing. We are using a virtual online gallery to showcase all of the work our students are doing and which enables them to engage with visitors to the gallery in real time. It is allowing our wider school community access to the amazing learning our boys are doing, regardless of where they are in the world.
VR made me curious about learning with a virtual reality platform. It made me more curious about demonstrating my knowledge of Hanukkah, which was my chosen global commemoration. It also made me feel more in control of my learning, and I wanted to keep on working on my commemoration. I wanted to keep exploring Fred and see what other possibilities I could learn and create, as I feel they are endless.
I might just go through with some codes with you and just show you what it looks like overall. Yeah, so it's a path, and I've attached the eagle to it, so when I play it, I'll show you now, that it will fly around it.
See, this is a PDF, so you can flip through the pages and see all about them.
So in our Noxigations unit, we were tasked to look at a natural disaster and try and find a solution. We also did lots of research on that natural disaster so we could make a National Geographic magazine all about that natural disaster. So we used the microbit, which can be compatible with all these different components.
I might ask you to download it. You just click download. We then head back over to frame.
You can also type up the dimensions you want. And then if I align them together in the middle and then in the middle, they're aligned, and then I can make it a home.
Now we've made a keyring. That's really cool. You made that in like 2 seconds. Can you?
Now, whenever you're on my microbit make code, the pause is always in milliseconds. So we just pause it for 3,000 milliseconds. So it could go in ascending order or descending, or it gets random.
The student-teacher relationship in our technology projects has shifted dramatically, and our teachers are in awe of our boys' skills, understanding and ideas. Whether it be peer-to-peer, teacher-to-student or student-to-teacher mentoring, there is a deep level of respect for the skills the other brings to the learning. In turn, the learning for all members of our community is deep and lasting.